For this video, this is not covered on the AP exam, but I wanted you to at least have some exposure to this. This is a way of calculating volumes by not using cross sections. And this is nice when we're revolving around a vertical line, such as the y-axis. And we don't want to do it with respect to y. We want to stay with respect to x. And that's a concept called cylindrical shells. And the idea of a cylindrical shell is, instead of thinking of it as cross sections, we're going to think of this like a cookie cutter. So I'm going to do the exact same example I did when I revolved around the y-axis and did the volume with respect to y, because I did cut cross sections and accumulated vertically. So my region is, again, this region between y equals the square root of x, the x-axis, and the vertical line x equals 4. I'm revolving it around the y-axis. So here's the rest of my region. And I get this kind of bowl shape. And the idea of this is, instead of slicing and looking at cross sections, I'm going to take like a cookie cutter or a biscuit cutter, and I'm going to cut down. And I'm going to cut out a cylindrical shell from this solid. Now, a cylindrical shell is like a cylinder, but it's hollow. So I've got this thin-walled can, almost like. So it's a cylinder that's empty inside. So think of it like a soup can with the top and bottom cut off. It has a height. It has a radius. And then it has a thickness to the wall of it. We can think of this as a change in the radius, or a delta radius. But we want it to be an infinitesimally small change, which means we're going to call it dr, is that thickness. And if I can find the volume of that cylindrical shell, I can accumulate those shells to get the total volume. So if I unwrap this, so I'm going to slice it down, slice it open, and unwrap it, much like we do a label on a can. And when I do that, I get a rectangular prism. Its depth is dr, its height is still h, but then its width is going to be the circumference of the circle that's inside, or about that, of 2 pi r. So then the volume of one shell is the length times the height times the width. And then the volume of all of the shells is the accumulation of that one shell's volume. Now note, it is with respect to radius, so my bounds are not about what is x and y between, but what is the radius between. So now when I look at this, it's not a cross section, it's a shell that I've cut out. Its height goes from the x-axis till I hit the curve y equals the square root of x. So the height is the square root of x. The radius goes from the y-axis until I hit the curve. So that's horizontal. That's just x. And then its width is going to be dx. So my volume of one shell is going to be 2 pi. My radius is x. My height is the square root of x. And the width is dx. So the volume of all of the shells, I need to accumulate that But now my bounds are what is the radius between. So the smallest radius I could have would be a radius of 0. The largest radius is 4. And when I evaluate that, I get exactly what I should, which matches what I got the first time I did this when it was with respect to y, of 80.425. In terms of visually, what a little better representation of how this looks, these aren't the same functions, and I'm aware of that. But if this is my region, this would be the height of my cylinder. So if I show the cylindrical shell, there's one shell. And as it's moving, I get shells of different sizes, but notice they're all hollow cylinders. So that's why we're calling them shells. So then when I get all of them together, I get my solid shape. I can keep having it trace the cylinder throughout this shape to get the idea that I'm pressing down with like a cookie cutter to get each shell.